Well, good morning, everybody, and welcome to today's webinar, Sustainable Innovation, brought to you by 3DS Man and Dassault Systems. My name is Rob Romanowski, and a lot of you may know me from being the Director of Operations with 3HTI. And recently, 3HTI has actually started another entity, another company called 3DS Man. And the purpose of having 3DS Man is to be able to offer our customers and prospective customers an even wider range of solutions to help them manufacture products faster, less expensive, and more efficiently. So the other thing is ultimately what we want to do is we want to help you live your life better overall, because that's ultimately what it's about. If you're stressed out about work, stressed out about all the issues that you have with your product development process, that's no fun. And I love working for 3DS Man and 3HTI. Great companies to work for. We have great customers, great people that work for our organization. We get to work with great people like Dipesh at Dassault, who I'm going to introduce you to in a minute. But the idea is life is about family. Life is about what you do outside of work. What you do with work doesn't fully define you. So one of the main focus for today is providing and discussing another analysis offering that we're able to provide with this product called Simulia. So today we're going to have the Senior Technical Consultant for North America. His name is Dipesh Shah from Dassault Systems, and he is going to give you an overview concerning the various analysis capabilities that Simulia provides. So at this time, I'm going to turn everything over to Dipesh. I'm really looking forward to this today. Dipesh, I'm glad you could be with us. And also I want to thank everyone here who is attending, and we're going to have a great session. So with that, Dipesh, you have control.
Okay. Thank you, Rob. Thanks for the introduction.
You're welcome.
And I'm glad to present this as well, because this presentation is all about the realistic simulations. So most of the times we are like making assumptions whenever we design a part. So this is going an extra level with the products supported within Simulia portfolio. And without further ado, I'm just going to be starting with that. So I'll be presenting about the offerings and capabilities of Simulia. And the agenda for this presentation rolls into the Simulia Power of Portfolio. So I'm going to go through a very good presentation or very good example of the stent, which is kind of like near and dear to pretty much like, we don't want to use it, but that's kind of like, happening things into it. So I'm going to be presenting about all the products rolled into one example, and then eventually go into the particular Abacus, then Tosca, FESafe, and EyeSight. Those are the 4 products. We call it as a power of portfolio. And I heard from Rob and Sari as well. Most of you are Pro-E customers currently. So what I've put into it, it's the Pro-E associative import. So if you have a Pro-E as your CAD package, then how easy it is to bring in the part into Abacus. So I'm going to show you that capability as well. And if time permits, I'm going to show you how simple it is to use Abacus by creating a demo for the cantilever beam. So without taking time into it, I'm going to go roll into the presentation. So as you may have heard, or at least aware of the product, so the flagship product for Simulia started back in 1978, and that's called Abacus. So that is widely used in many industries right now, and that's mainly capturing your nonlinear, linear analysis and simulations into it. But now, within the last 6-7 years, we have also started acquiring companies which can do the fatigue or durability. So that software is the FESafe software. So that can be rolled in with Abacus. And then the other product is the EyeSight, which we have in our portfolio for last 9, 10, 11 years into it. So EyeSight is mainly used for the process automation and the design exploration. And with EyeSight, you can combine kind of multiple cross models and simulation process flow, and that can be automated So we'll talk into all these products. So main concept or main aspect of this presentation is about Abacus, but then eventually I'm going to just give you a teaser about EFISAFE, EyeSight, and Tosca. And Tosca is a non-parametric tool, whereas EyeSight is a parametric tool to do the design of experiments or the optimization. So I'm going to go next into the workflow where you can use the all products into the combination with each other. So the way the product or the project is being designed, so first of all is the stent analysis is being performed in our flagship product in Abacus. And once we have got the initial stress results, then we'll start looking into the parametric design optimization using EyeSight, where we can change the parameters. The known parameters are length, radiuses, thicknesses, and all sorts of things. We can change them, and then once that is performed, the next step is to go into the fatigue life, because whatever product we design or analyze, we want to make sure it has enough life into it, like hours, years, or maybe seconds, or loads or cycles. So that can be developed by using the EFISAFE, and then eventually taking the same stent into the next level, doing the local optimization using a product called Tosca. So far I talked about Abacus, EyeSight, EFISAFE, and Tosca. And we also want to make sure once we have designed our stent that is good enough to take it to the next level or take it into the production, where we can do the reliability analysis using EyeSight. So this is all kind of a very broad overview. I'm not going to get into any of the nuts and bolts or any of the details, but just to show you how things work out, and then eventually we can look into the particular product as Abacus into it. So stent deployment analysis. So as we all must be doing, like, if you are using Pro Mechanica, then you'll be doing some sort of stress analysis, maybe a static stress analysis, or maybe dynamic, or going into linear, nonlinear, depending on your requirements. So here we are doing the crimping and insertion analysis using Abacus, and then taking into the next level where we put it into the artery. And so first crimping it, and the second thing is expanding the same stent into the artery, and eventually loading it into the blood pressure, or basically ballooning that same thing. So this is using Abacus. We have performed the crimping and the insertion analysis into the stent, and then life can be influenced well by a small shape change into it. So that can be performed using the Tosca. So extend with the global design changes, which we will go into changing with the EyeSight parameters, where we change the radiuses and the length into it, and then eventually run the cyclic stress or the fatigue life or the any of the durability analysis using EFISAFE code into it. So once we did the life cycle analysis, which can be done at the any state of the analysis. So we can go into the crimping, or we can go into the expansion. So that is where we can design that. But now going into the parametric aspect into it. So you must have used some kind of parametric study whenever you design the part. Oh, what if I change the radius? Or what if I change the length into it? Will I get the better performance, or will I get the worse performance? So we all have done the iterative study or trial and error study, which can be kind of making into the automated process using EyeSight into it. So control via geometric parameters using the SolidWorks. In this particular case, the part is designed using SolidWorks. So changes on the mesh transferred via the help of the script, if you are using any of the scripting into it. So the workflow into here, so start with the parametric 2D model, then bring in that model into Abacus, CAE, then you mesh it, and then simply extrude it, because this is a simple extrusion part. So extrude it, make it a 3D, make it a cylinder form, and eventually run the analysis. So for this particular stent analysis, there are three of the parameters can be investigated. So first one is our length into it, and second one is the thickness, and third one is the radius into it. So first we can set up a design of experiment using eyesight, and then that will automatically modify any of the parameters. The best part about eyesight is you just need to put parameters and you can put the workflow into it. So here is a workflow. So first of all, start with the design of experiment and then modify the stent model using the SolidWorks. But in your case, if it's ProE or CATIA, any of the model, you can use that. Then pre-process the stent model. So that's just the component into it, and eventually run the abacus analysis. So this will give us the best possible solution. So in other words, we'll be doing like, one study, run the analysis manually, find the results, and then go into the next analysis and maybe put an Excel sheet together and say like, oh, these are my high stresses, or these are my high strains or displacements, whatever parameters or whatever variable we are looking into it, we'll be going into it. So that's kind of a tedious process, iterative process, but with eyesight you can automate everything, and that is where the process automation comes into the play. So eventually my goal is to reduce the stresses. So that is where the sweet spot comes into it, including all the parameters, and that's where eyesight guides us into the right direction. So this was more of a global approach going into the eyesight design exploration. And now I'm like, I can go ahead and make some very local changes using the shape optimization using Tosca. So far I showed you the capability of abacus where we did the crimping or the expansion analysis. Then we did the life cycle analysis using FESAFE for the fatigue and durability. Then we did the parametric study for the global model where we went ahead and changed all the parameters into the part, and that's where we found the best possible solution. And now I want to take it to the extra level, or take it to the next level where I can still reduce my stresses going into the stress homogenization and to the peak reduction. The best part about the Tosca is basically you can put the geometric restrictions, because sometimes it will come up with a design which cannot be manufacturable. So you can go ahead and put the restrictions into it as well, and you can also put the cyclic symmetry. So eventually the design evolution, if I look into it, so the baseline, wherever you see the red, that's where the kind of a life cycle was very limited or very low into it. And eventually by making the global and the local changes, we were able to achieve about 14% of improvement into the life cycle. So that's just the all power of portfolio, or all the products Simulia has to offer. And I just showed you as a very high level analysis aspect into it. And what I'm going to do now, I'm going to go into the nuts and bolts of abacus analysis, because that is the whole purpose of this webinar, is just to show you the capabilities, what abacus can do, and those are limitless capabilities, and the industries is being used in like any industry you can imagine. Abacus is being used nowadays. So I'm going to be starting with into the abacus and what can you do. So as you can remember, the first slide, it talked about the realistic simulation into it. So what is the realistic simulation? So realistic simulation is nothing but a simulation that can be physically realistic and lifelike. So I remember I've worked in the industry for about 15 plus years, and the sophistication it has come across with the contact and the material definition and all sorts of loading capabilities and all sorts of analysis procedures, it's kind of a tremendous change into it. So it's always all the companies moving into the direction of virtual validation, and you must have heard that, because Honda is a great example, going into the product life cycle, going from years of like 5 to 6 years to just taking as a number, nothing to be solid, but maybe reducing by months into it, you know. So that is where every company is going into it, not eliminate the physical testing, but at least reduce the possibility of it. So as seen in this example, the automotive example on this slide compares very well. So here is our B-pillar crash test into it, or the side impact. So it does behave, or it compares very well with your simulation into it. And the other one is the side pole impact for the whole car. So as you can see into it, these are done with the explicit simulation, and it performs very well into it. But the way it is, typically the customers, they'll start with a very simple model and increase the complexity. What's the reason for it? Just to gain the trust of the product or the software it can bring you into the analysis aspect. Here is another one to reduce the physical testing, because as I mentioned, you know, like every time the prototype can cost you tons of money. So to reduce the physical testing, save time and money, time in a ways of doing into the product life cycle and eventually improving the quality. So this example is shown with the Mechanical Design and Analysis Corporation into Japan, and is using Abacus to simulate the elastic buckling of a cylindrical cells under the axial compression, and it does compare very well. And another example is the dummy for the side impact analysis, and that compares very well into it as well. So these are, as I mentioned, you know, it's kind of like a proven process into the industry where they have kind of eliminated the prototype phase into it and go direct into the production aspect of it. And here I'm going to show you some kind of like, you know, cool animations into it. So if you have a robust nonlinear simulation tool, will we be able to stop making assumptions, you know, like, oh, what is the nonlinearity and what kind of a contact forces occurred into the analysis. So here is the first one, which is known to every household, Jenga using Abacus. It's a great contact functionality. Then here is another one. We all have used it one point of time. This is the wipe dispensing for our Kleenex or any of the Lysol wipes. So that it does change the contact state as the wipe is being pulled out of the container. And then here is the delamination, or kind of finding out the adhesive or the cracking into the part of it. So this is the VCCT or virtual crack technique into the Abacus software. So these are some advanced capabilities available within Abacus. You might not be using that nowadays, but eventually you can take it to the next level and basically use that. And then if you have a robust dynamic simulation tool, so this slide is just to showing the capability with multiphysics. So you have a CFD problem, and then you want to include the structural aspect into it. So that is where it's the vehicle here is kind of a duckboard tours, and we might have seen it at any of the tourist place, like go to Wisconsin Dells or Boston, anywhere. So that's on the road, and eventually getting that into the water, and analysis has been performed on it. And here is the heart project. So Simulia is very much into it, and right now we have a live heart project. So if you want to see a very cool simulation, you can Google, like, you know, live heart or living heart project, Simulia Abacus, and that way you'll be able to see all the details of it. And then earthquake simulation. This is a better one, like hose with the fluid, using our SPH, or the smooth particle hydrodynamics simulation capability within the Abacus tool. So that's showing that. And then here is a simple ratchet mechanism where it stops into it, and the high stresses are generated and high strains are generated, and eventually a permanent deformation into it. That's where the tooth fails into it. So the technology sophistication, or simulation solution, covering designers to simulation expert. So here, as I move forward into the aspect or the axis, so these are just the simple simulation which can be done on a daily basis, like, going into the turbine, kind of feeds our blade into it. Here is a clip insertion analysis. This is more of a bushing simulation. And then stent, what we just saw, then taking into the next level where we saw the delamination or the adhesive properties into it. This is a great example of the aerospace industry. That's where the skins and stringers and the longerons and all that simulated, and that's the good old flagship simulation. So if you go to any abacus, that's the first simulation, and that's where the explicit analysis started with the Motorola phone drop simulation. And this is kind of an expert capabilities within it, with using the CEL or the combined Eulerian and the Lagrangian capabilities into it, or the coupled thermal mechanical analysis, and this is more of a composite delamination technology into it. So these are the various simulations can be performed into it. So think enough with the animations and the videos of abacus capabilities. I'm gonna what industries is being used, and I'm gonna tell you a little bit more about abacus into it. What are the solvers? What are the products? So as you can see, multi-physics solver covering all the industries. So consumer packaged goods, the best example is Procter & Gamble. The diapers or the bottle of Tide, they do the bottle drop testing and all that. And then the automotive and transportation industry, that's where they do the analysis for chassis, body, or dummy itself and finding out the injury criteria. Then the industrial equipment, which is John Deere, Caterpillar is one of the largest customers into it. Life sciences is the Boston Scientific, Mad Institute, Cook Mad Institute. Then high tech, Apple, Amazon, just to name a few, they are using abacus. Aerospace and defense, architecture and construction, and into the energy industry. So this might not be the industry you may be working with it, but affiliated with it. So eventually your end users must be using abacus, and then may make it life easier into use the software and take it to the next level. So that was the basic overview what industries is being used into it. And now I'm going to get into the details of the abacus products. So abacus does come with abacus standard, which is our implicit solver. Then we do have explicit solver, and then the computational fluid dynamics, which is the CFD. So it's mostly nonlinear engineering capabilities and designed for the production use. And then mathematical basis, which is finite differences method, is being used and does have years of experience into it. So that's why it's a industry standard into it. And then we have a product called Abacus CAE. So which is the way the name CAE came across was the complete abacus environment, and that is being used for the pre-processing where you can create the model, and post-processing where you can post-process the results into it. So these are the abacus products. So if you buy abacus, then standard, explicit, and CFDs by default, you'll get that. And then depending on the token, so that might be ROP stock or sorry stock. I'm not going to get into it. But the other good part about abacus, it's a scalable portfolio. So in a way, it's like, let's say you have a great resources with like 20 CPUs onto your machine. And depending on the token you have, you'll be able to expedite the process. So designed to handle model of any size. So here is a simple example from the Dana Holding Corporation. It's a 9.4 million degree of freedom model, which is a huge model. So it would take 3 days if it's being run on 4 cores. But if the same model is being run using 128 cores, the solve time was about 4 hours rather than 3 days. So you can see the results. So marches into the solution faster and does scale efficiently when using the multiple core. So here is a 4 million degree of freedom model into it. So runtime with 2 CPUs to the 16 CPUs, almost like 1/4 into it. And as we saw, the impact analysis. So that's kind of like, just the scalability portion of it. So more number of CPUs will get you results faster. So it does scale pretty good with respect to the resources you have and the tokens you have. And here is like, the extensive material models. So as I mentioned earlier, like that is being used in various industries. So cast iron plasticity. So this is a coupled thermal mechanical analysis. Human tissue. So that's going into the stent analysis. Then viscoelastic rubber. So it does support kind of rate and temperature dependency into the analysis. Then reinforced concrete, soil and rock analysis. So, and then viscous paste. So you can use multiple material models which is available within Abacus. So that way, at least it will make your life easier and the simulation will be much more realistic rather than making assumptions into it. So here is a great example of the test and the simulation, because the material model defined into it, it had a non-linearity into it and the plasticity also, and then the fracture and failure also defined into it. So you can see the more accurate data will get you more accurate results into it. And this is the Abacus standard. So based on the implicit solution techniques, so you can do simply the frame stress analysis. I want to do the beam simulation. So you can simply go ahead and define the linear structural model. And then if you want to take it to the next level, then you can do the non-linearity into it. And this is with the standard where you can add linear and non-linear behavior. And then explicit, that is where you can make it to the next level where high-speed transient dynamics is kind of an area of interest. So you can define that and also suited for your highly nonlinear quasi-static events. So if you're doing some kind of a bottle drop analysis, then this is also taking into account the fluid structure interaction or FSI, then blow molding, then the deep drawing, energy absorption, the way you saw the previous cramping of the beam into it, blast loading, metal rolling. So these are just to name a few example into it, and hence you can also use it for the contact simulation, which is extremely robust and accurate as well. So the accurate comes in here, so you can see the cramping analysis or the rail crush analysis for the transportation system. So this was done in Switzerland, and here is the frontal impact analysis, and this is for the life sciences where we have the knee impact analysis into it. So this all, just to sum it up, Abacus does a great job with the nonlinear models, or if you just have a basic analysis where I'm going to show you the demo of it into the beam simulation, but contact. And now the area of interest. So I'm going to show you the associative interface import with Abacus. So here is my Abacus CAE and here is my ProE. I'm going to show you the associative import into it. So first of all, to start with, I have to make a connection with my CAD interface. In this case, I'm making connection with my ProEngineer. So that way, ProEngineer associative interface offers two import methods. So one is the automatic, other one is the manual. So automatic is the open in CAE, and the manual is with basically exporting that with the Elysium assembly file. So every incremental changes into the ProE can also be written to the Elysium assembly file or manual associative import. So now in this case, I want to do the automatic. So I'm going to be exporting that to Abacus. And what do I want to export? So it's the solid and points and everything, and what units do I want to write into it. So now I have all the details into it, how many solids I'm importing or how many points I'm importing, and then putting that into Abacus CAE. So the only criteria is that you have to have both the GUIs open, so you can see how simple it is. So I brought it into it, and now I have like all the parts instances into the assembly as the same way as I have defined into my ProE. So the naming convention stays the same. And also I can do the view manipulation because the pan, zoom, rotate is not the same with Pro E because it does go with the CATIA. And now I want to make some changes into the Pro E aspect. So you can just see on the fly, I moved my backhoe into it. So now if I update the model, the only other thing to keep in mind every time you make a change, you need to open that into CAE again, and that way everything will be replicated the way it is into your Pro E model. So now I'm going to be creating a step where I want to perform a static structural analysis or linear analysis. So I'll perform that, and I'll create some kind of sets and loadings and boundary conditions, and that will still be retained even if I made some changes into it. So I created a step within Abacus CAE, and then I'm going to go ahead and create a loading onto the side face with the pressure loading. So that all can be created in here. So I created a pressure loading, and then I'm going to create a surface and a set because I want to apply some kind of a boundary condition into it. So I'm going to go create a set with this surface, and I'm going to go create a surface using one of the curvature surface into it. So now I want to take it to the next level. I was like, whatever design I have for my backhoe, I want to change it. I want to change the dimension. So I changed the part dimensions or the parameters into it. So just wait for it, but you'll see the wonders. The same change is being implemented into your Abacus CAE as soon as you open that again into the CAE. And I have some suppressed feature into the part, which was the hole I created beforehand. So that is also defined into it. So now I go back to my assembly into Pro E. So those changes are implemented, but I still don't see it. So I need to go into the Open CAE. So that way the changes are implemented. So you can see that my backhoe became smaller, and also there is a hole onto it. But wait until you see the loads which were defined on the surface, they still remain intact. So in a ways, when you want to make some changes into the Pro E, so this is kind of an added capability. So you have to have a license for the associative interface. But I just wanted to show you because the way you make the changes into your Pro E or to make the changes into your Abacus, that those do get replicated into your Abacus CAE model, because most of the time for us analyst or design engineer, what happens, like you make some changes and you have to go ahead and recreate that model because that is not being implemented into the current model. And the same ways, the SolidWorks associative interface is also available, which can pretty much be worked into the same aspect as well. So I just wanted to show you that because as I heard, like some of the Pro E design engineers are also going to be part of this webinar. And now I'm going to take it to the Power Up portfolio or the other tools which can be used in conjunction with Abacus CAE. So Tosca is a known tool for the non-parametric optimization. And within Tosca, there are various modules available. So first one and the foremost used is the topology module, because every time and any time, wherever you work with, like, how can I make this part lighter? How can I make it cheaper? Because material savings is your cost savings eventually. So find the design with the maximum stiffness or minimum weight. So you're not compromising on the quality of your part, but at least you're getting minimum weight. Then the second module within Tosca is the sizing, where you can reduce the mass through the optimized sheet thicknesses or the sheet metal thicknesses. So as the name says it all, sizing works for the shell or the sheet metal components. Then there is a shape optimization. So this comes into the later part of the design. Shape optimization does not help you with a whole lot of material or cost savings, but it does help you big time with the local stress reduction, or in other words, we call it hotspots or high stresses. So that can be reduced into the aspect as well. And then there is the bead optimization, which is mainly used for the shell components or the sheet metal where you can add the beads into it, or Tosca will add the beads into it and increase the stiffness, or will help you with getting higher normal modes into it. And the last one is the fluid topology. So if you want to do the fluid flow analysis, then fluid topology will be the module you will be using into it. And then here is a simple example. So this was the original design. So I started with the design space. Design space is nothing but the confined volume, how much of the design space is available for you to sculpt a part out of the component into it. So the topology optimization, and then eventually you can extract the geometry into IGS or STEP, and this is where the final design comes into it, because we always want the part to be manufacturable. So that is can be defined into it. And then FE-Safe is another tool into the portfolio which can be used for the fatigue and durability analysis. So if you are just designing your part for your low-level fatigue cycle, then the known source of failure, known location of failure is going to be around the bolt hole. If you are doing with the high-level fatigue loading, it's going to be around the bolt holes or bolt loading into it. But now I want to get the accurate results onto my residual stresses, where I'm going to be combining the low cycle and the high cycle fatigue into the nonlinear aspect of it. And there you can see that it's not into the predictable. So this is where pretty much every kind of a failure, because your part is not always going to go through the low cycle fatigue or high cycle fatigue, but it's going to be a combination of both. And that is where FE-Safe will help you kind of guide the part into it. So this was an example from the Hyundai Motor Company. This is a live example. And here is the eyesight which is being used for the process automation. So Baker Hughes, we all have heard the name, which is kind of a big manufacturer for the tooling of your oil or the gas companies into it. So they were using, or they were designing a part with the manual iterative process where they'll go ahead and change the dimensions of it, or change the diameter, or change the length of it. So 2 months of analysis had been required to come up with the ascertaining the acceptable geometry with eyesight. They were done in 2 days, and this is the real testimonial where they were able to go from months to days into it. And the best part about it, what they didn't see was, like, they had never thought about it, how the part can be designed, but with the eyesight, they went ahead and kind of found the brand new domain into the analysis and process integration, or the design optimization for eyesight. So the good part about eyesight, as I mentioned, it goes into the cross product into it, so you can do the reporting, you can use your design experiment into it, you can use Abacus, you can use MATLAB, and it's not always it has to be Abacus only. You can put any component whichever is being supported, and then automate the simulation process flows into it. So that is what kind of a power of portfolio into the analysis. And I think we have some time left. So what I'm going to do, like, as you are not the current Abacus user, I'm going to bring up Abacus CA, and I'm going to show you how simple it is to create a model, in at least just to make you familiar with the GUI or the interface into it. So let me just bring up, I have a dual monitor. So I'm just going to be bringing into Abacus CA. So Abacus CA works on the module base, so part, property, assembly, and I'm going to go through each module into it. So first, I can go ahead and create a simple part. So I'm going to go ahead and create a solid beam, and then so we start with the 2D sketch into it, and then I'm going to give the extrusion depth. So here is my beam. I'm going to be doing the 3D beam. So I've created a part. Now I'm going to go into the material module. So as I mentioned, here you can add all sorts of materials into it. So I'm just going to go make it very simple. 210 e to the 3 and Poisson's ratio of 0.3. So that's my material. I'm going to name it as a steel. So that's my material into it. I'm going to go create a solid section. And then I'm going to assign that section to the part, set 1. So here is my part with the property. Abacus has a requirement of having assembly into it. So I created an assembly, and now I'm going to go create a static step into it. And then I'm going to go create a load. I'm going to go create point load onto it. Concentrated force. That should be okay. What points? So 1, 2, 3, and 4. And then I'm going to go give the force of -50 into the 2 direction. So now my part is being pulled downwards onto one side, and other side I'm going to go create the boundary condition. So that is on this particular face. I'm going to go create the boundary condition where I'm going to make it a pinned and then create the mesh into it. The size of 3, and then simply mesh the part. So here I have everything required to run the job, which I did the part, property, material, assembly, loading, boundary conditions, and I'm just going to be running this model. And I can do everything within Abacus CA. So I'm going to be, and that is where kind of a parallelization. So if I have a 4 CPU on my machine, so I'm going to use that, submit the job, and I'm going to get results into it. So the job is done because it was a very simple analysis. I'm going to bring in the results. So it will bring me into the viewer, and that is where my cantilever beam analysis. So that's my stresses. This is my displacement into it. So I just wanted to show you how Abacus in general means depending on the multiple components, multiple things, you'll be making it a little bit more complicated into it. But I think that's about it for me to show you. And now we'll open it up for the questions if you have any, or if you want to know something like, which is related to what you're doing or where you can see the good use of it. And I think Rob, he'll take it from now on, and then I'm here on the line.
So at this time we'll have Depesh. Thank you very much. Thank you very much for that great presentation and overview. I mean, as everyone can see, this is a very complex tool that can solve a lot of different problems with analysis. So if you have any questions, no matter how specific they are to what you do, take this time and type them into the question box, which is in the dashboard, and we'll gladly answer those questions. So we have had a couple of questions come in.
Okay.
One question is, you talked about the associative interface with Creo. Does Abacus also interface with other CAD platforms?
Yes. With SolidWorks, it does a great job. With CATIA as well. And then if you have UG, then it does as well. Let me just look at that. What particular tool is the person looking into it?
They were, I think, looking into SolidWorks.
Yeah, so SolidWorks is a good thing because SolidWorks is still a Dassault product. So yeah, it does a great job, Same as the Pro E.
Nice. Next question is concerning medical devices. Can Abacus take into account human tissue properties to get a realistic interaction?
Yes, we have been doing it.
All right, so there's the quick and direct answer. The answer is yes.
Yes, that's correct.
Nice. I like when the answers are simple. Next question. Why is it so hard to analyze something like liquid-filled soft packaging, like an IV bag?
Because it does take into the account for the coupled approach where you have the Eulerian domain and Lagrangian domain. So Eulerian domain is kind of a fixed volume and the flow is within the component, and the Lagrangian, it does have a boundary condition. So now with the kind of an IV bag, we do have a volume and then we have kind of a fluid flowing inside. So it's the coupled approach, and that is where it does get a little tricky. It's not impossible. It is a little bit difficult, but once you get the process, so Baxter is using it big time. And then other companies, the BD, Becton Dickinson, they're using it on their daily uses as well. So these companies are using Abacus on daily basis, and they're purely doing the CEL or the IV analysis as well. But it's just a matter of getting used to the tool. It's not difficult once you start using it,
Cool. Next question. Somebody states they're a firearms manufacturer, and Abacus has Abacus been used in the operation of a firearm or for small controlled explosions?
Yes, we can do blast analysis. Firearms means couple of the government projects been done, but yes, it's being used in one of the customers I'm going to be helping. They do make firearms, so I have to do the inertial analysis, and I also have to do kind of impact analysis. So on the firearm itself, and also do the impact analysis onto the kind of a wall or the target. So that is being used into the industry as well, yes.
Cool. Next question. Can Abacus handle thermal structure simulation? For example, like a braking system?
Yes. So we have couple thermal structural simulation aspect, and if I go back here, so here is my, so that is where the couple thermal, that's for the manifold for the engine. So now I wanted to look at the thermal aspect, taking into account for the plasticity. So that's being used into it. And then there is another example as well for the wave loading and thermal analysis and structural analysis into it. So yes, it's been used widely into the industries.
Excellent. Excellent. These are good questions. So
no, yeah, and I think it's a very good question, and in a way, it's a very widely used capable software into it. Abacus can do wonders.
So if anybody has any more questions, I mean, at this time, if you want to type them into the box, you still can. But you can either respond to the confirmation email that was sent to you concerning this webinar, or you can send us an email for any additional information to info, I-N-F-O, at 3dsman.com. And we'll get back to you and we can go into some more detail. The other thing that we're going to offer everybody who is attending the webinar today is we'll offer a free 1/2 hour consultation. So if you're interested in talking to a finite element analysis expert, we will set set up an appointment with you for a half an hour with one of our resident experts to discuss whatever problems that you're having. Um, this isn't a, necessarily to try to sell you something. This is to just thank you for being on the webinar and say, look, if you're running into an issue and you want some help, you want some advice, we're more than happy to share about a half an hour with you, because our goal is to try to provide more value than any other reseller on the planet. So if we can help you out with a problem and share, about a half hour with you and get to know you a little better and help your business, then we've done our job. So I think that's all the questions for today. So once again, I would like to thank Dipesh Shah for being with us and doing such a great job in his presentation today, and thank everybody else for attending.
And thank you, Ralph, for the opportunity. And as I say, like, this is just the start in a ways, right? It's just to show you a very broad overview. Mm-hmm. And I think there is a whole lot things can be done and achieved with Abacus. So that's perfect,
Excellent. Actually, one more question came in. It says, we are a tier 2 supplier to an automotive company that uses unique materials. Can those unique materials be loaded into Abacus for structural analysis?
Yes. So materials, we have a very wide database. Let me just show you. So what can be included into it? So if I go into you can see my screen, right, Rob?
Yes, I see your screen.
Okay. So into the material definition, so we can put all sorts of it, and then if it's very specific, there is a feature within Abacus called the user subroutine, where you can write your own materials and bring it into Abacus. So it can do all sorts of things into it. So this is a mechanical, thermal, electric, magnetic, and then you can also use kind of like, gasket material if you're just the gasket manufacturer. So all sorts of, user material can be defined into it, and you can bring it into it. So Abacus does support all sorts of material. Whatever can be written out, that can be brought it into Abacus, yes.
Excellent. Excellent. So I think that's it.
No, perfect. And it was a pleasure, and thank you everyone for attending the webinar.
Yes, thank you everybody. Once again, info at 3dsman.com, and we'd love to hear from you. Thanks again, Dipesh.
No problem. Bye-bye, guys.
Take care, everyone. Have a great weekend.
You too. Thanks a lot.